G'day guys, in this video we'll be going over completing the square, right? So things like what is it, where does it come from, how does it work, and why we would want to use it. So completing the square is just a factorization method, and we can use it to find the solutions to a quadratic expression. That's its purpose. And when I say roots of a quadratic expression, I mean x-intercepts and I mean solutions. So these are all just different ways of saying the same thing. As far as how it works, I think the best place to start is with the general equation for a parabola. So y equals ax squared plus bx plus c. Right, and so we want to find the x-intercepts. And the definition of an x-intercept is that y will always equal 0. So that's actually the first step, is we can let y equal 0 in this equation. So 0 equals ax squared plus bx plus c. And the next step is to actually let this coefficient of x squared equal 1. And I'll show you why in just a moment. But right now it's equal to a. So what we can do is we can divide every term by a. And 0 divided by a is still 0. But now these a's cancel out, and the coefficient of x squared is indeed 1, which is what we want. So it's x squared plus b over a, x, plus c over a. Nice! What we can do next is actually just subtract c over a from both sides. And the reason we want to do this is just to isolate those x's that little bit more. So we're left with negative c over a equals x squared plus b over a x. Awesome. So the key idea of the quadratic formula is that with this right-hand side of this equation, we have x squared plus b over ax. And this is really annoying to work through algebraically. So this is the really cool idea. Wouldn't it be awesome if this right-hand side was actually just x plus z squared? And z can be anything, right? Z is just a placeholder. But the reason why this is a lot easier to work through is that we can just take the square root from both sides and then subtract a z, and we are left with x, which is exactly what we want. That's what we were trying to find in the first place. Okay, so then the question is, how do we get to this stage where this right-hand side of this equation is expressed as x plus z squared? So if we expand this out, we're left with x squared plus 2zx plus z squared. And this is really cool, right? Because this x squared matches up with this x squared. We have 2zx here, and we have b over ax. So if we can add on z squared to both sides, right, to keep the equation balanced, what we can actually do is this whole new right-hand side collapses down into this x plus z squared. And this is actually how completing the square gets its name. We are changing this initial equation so that it becomes the perfect square, right? Which is why we can collapse it down. We're changing this initial equation so that it becomes a perfect square. That's how it gets its name, completing the square. All right, so then the next step is to find z in terms of b and a. So if we know 2z corresponds with b over a, then it must follow that z equals b over 2a. And more than that, z squared equals b over 2a squared. So if we can add on b over 2a squared, right, then we can collapse this whole right-hand side down into x plus b over 2a squared. And this is where the algebra becomes a lot easier, because then we can just take the square root from both sides and subtract b over 2a from both sides, and we're just left with x, which is what we want. I might stop here for the sake of time because the algebra is really straightforward. So let's try an example. Excellent. So y equals 2x squared plus 8x plus 6. And the first step here is we want y to equal 0, right? By definition of an x-intercept. So 0 equals 2x squared plus 8x plus 6. So just following that previous algebra that we worked out, we want this x squared coefficient to be 1, not 2. So we can divide everything by 2 to get them to cancel out. So 0 divided by 2 is just 0. This should always be 0, right? Because 0 divided by anything is still 0. These 2's just cancel out. Plus 4x plus 3. And what we can do is we can subtract 3 from both sides just to isolate those x's that little bit more. Awesome. So now we want to add on b over 2a squared. So if you'll notice, this 4 here is actually already equal to b over a because we divided b by a. So if we want b over 2a, we can divide everything by 2. And 4 divided by 2 is just 2. And so if we square everything, 4 equals b over 2a squared, right? Which is what we want. So then if I just write out that initial equation, negative 3 equals x squared plus 4x, we can just add 4 to both sides. And 4 minus 3 equals 1. And now this part just collapses down to x plus 2 squared. So now what we can do is just take the square root from both sides. So square root of 1 is actually just plus or minus 1, right? Because negative 1 times negative 1 equals 1, and positive 1 times positive 1 also equals 1. Nice. So now we can subtract 2 from both sides. X equals negative 2 plus or minus 1. And in the same way that we have two solutions for the square root of 1, we have two solutions for x. X equals negative 2 minus 1, or x equals negative 2 plus 1. You'll have to excuse my handwriting. X equals negative 3, or x equals negative 1. So these are the x coordinates of the roots, and we already know the y coordinates. The y coordinates are just 0. Therefore, the roots are negative 3, 0, and negative 1, 0. Awesome. All right, guys, that's all I got. Cheers.